Hi everybody, my name is Stéphane Bégaudeau and today I'm going to talk about the work we have done to bring your modeling tools into the cloud. This is the agenda for this talk. First of all, we will see how we have brought the web inside of Sirius as it exists today. Then we will have a look at the work we have done to bring Sirius inside of the web. We will also see how we can integrate Sirius diagrams inside of web application. And finally, you will have an overview of what's coming next year. The first thing we did this year was to try to integrate the web with Sirius by introducing web technologies directly inside of existing Eclipse views. We started from a regular Eclipse instance in which we worked to integrate a new DSL. We have integrated web technologies inside of Sirius thanks to this brand new DSL named Workflow. This DSL lets you parameterize an editor in which you can show some actions for your end users. As usual, this DSL can be parameterized by expression using GraphQL or Java services. You can also use model operations in a similar fashion as in the tools of your Sirius diagrams. This time, the rendering is done thanks to web technologies instead of SWT widgets. This work is powered by Jetty, a Java server which we have embedded inside of Sirius. It is used to provide a dedicated REST API using the Workflow DSL. This API is then used by React components in the front-end integrated in an Eclipse editor. Here you can see the Eclipse editor with the result of the Workflow DSL rendered thanks to React components. And here you have the definition of the workflow on the left in the ODesign editor, and on the right the result. You can see some of the elements computed from the Workflow DSL on the screenshot. Now let's have a look at this in a video. So on the left, you have the definition of the workflow, and on the right, the result rendered in the editor. We can see here that the labels are computed from SQL expressions, and if we have a look at the behavior of the action, we can see that when the user will click on the green arrow, it will open a dialog in which the end user will be able to create a new object fairly easily. This work is done thanks to the support of Dialogues, Wizard, and Properties View from Sirius 6.0. After this, we have started to work on integrating Sirius in the web this time. Our first task was a refactoring of the code to be more independent from Eclipse by removing some dependencies to the Eclipse user interface, for example. We have also identified the various services which should be provided by the backend and then create a React-based user interface. We have also refactored our HTTP API to move away from a dedicated REST API for the workflow to a general-purpose GraphQL API. With REST, we used to have multiple endpoints with specific requests and responses expected by the server. Now, with GraphQL, we have one endpoint providing some capabilities that you will be able to manipulate quite easily. Here you have an overview of the architecture of the server. You can see our two HTTP endpoints which provide support for images and the GraphQL API. We are also working on a prototype of a WebSocket support for GraphQL API. Then in the center, you have the GraphQL interpreter, which is connected to all the existing Sirius components, such as the support for diagrams, viewpoints, or the AQL interpreter. It is also connected to other Eclipse components, such as EMF. GraphQL is a query language for your APIs. It has been created by Facebook and deployed at several major companies, such as GitHub, New York Times, and others. With GraphQL, you can have one entry point where the concept of your APIs are exposed as a graph. With GraphQL, you can ask for anything you want, and we will return just that, nothing more. With GraphQL, a server defines a schema describing the structure of the API. Then the users can create queries matching this structure, and the server will return the result. You can see here that we have a type named user in our schema with two fields, name and friends. We can thus create a query retrieving one user and then asking for his name and the name of his friends. Please note that the structure of the result will match exactly the structure of the query. No need for you to review some documentation to find out the structure of our HTTP responses. Thanks to GraphQL, you can create some powerful queries with arguments. Here we have two sets of arguments, one for the user and one for his height. In order not to hardcode the values of our arguments into our queries and to prevent some GraphQL injection security issues, we can also use variables which allow us to provide a value at runtime when the query will be executed. Here we have one variable named $name, which is used to hold the name of the user that we want to retrieve. GraphQL also allows us to retrieve multiple resources at once quite easily. In order to prevent any conflict in the response, we can define some aliases to rename the result of a field. Over time, your queries will get bigger and more complex to maintain. You can extract common parts of your query into fragments which can be reused easily. Here we have created a fragment named user fields, which we can reuse for the two users that we want to retrieve. On the server, we have defined our GraphQL schema thanks to its simple and powerful type system. The entry point of a GraphQL schema will always be the type query. Here, from the type query, we have a field named user, which gives us access to the type user. This way, we can start navigating between our concepts. We can also indicate that a type is non-null or that it will return a collection of elements. In this schema, the type user has a field named friends, which will return a list of users which cannot be null and which cannot contain null. As a result, you know that in your JavaScript code, you will at least have a regular empty array. GraphQL also lets us define union type, which are useful if you want to define a field where the result can have various types. Here we can perform a search, but the result can either be a user or a project. Using a union type, we can create a search result representing either of those concepts. When you will perform the query, you can indicate that what should be done for each type which can be retrieved by the query. In this query, if the result is a user, we will ask for his name, while if we have a project, we will ask for his code name. In a similar situation, if all the potential types are sharing some fields, you can define an interface containing those common fields, and make sure that the type in question are implementing this interface. As a result, when you will write your query, you will be able to ask for the fields of the interface regardless of the actual type of the result. You would still be able to specify what should be done for each specific type too. GraphQL also comes with some introspection capabilities. You can very easily retrieve the schema of the API itself and start requesting some information from it. It provides this way an up-to-date documentation of your API fairly quickly. In this example, we are only requesting the name of all the types of our API, but we could also request much more, such as all the fields with their types and so on. In Sirius, GraphQL acts as the entry point for multiple services. We have the workspace service, which provides access to projects, folders, and files. The Sirius service, which can let you activate viewpoints and create representation. And finally, the EMF service, which lets you navigate inside of models and in the package registry. Here, you can have a look at our GraphQL API as a whole, with all of our concepts and the links between them. On the left, you can see our entry point, a small, almost empty concept only used to give us access to more elements. And the large part on the right is the EMF part, where you can see all the types from the model elements and the way we can navigate in those models. GraphQL also provides support for parsing and validation of the queries. It also comes with standardized error messages. Have a look at the GraphQL specification to know more about the structure of those error messages, and keep in mind that a GraphQL response can contain both errors and valid pieces of data, since only a subpart of the query may produce an error. Thanks to all those features, you can use some great tools from the GraphQL community, such as Graphical or Insomnia, in order to set up your GraphQL queries. So let's have a look at the creation of a GraphQL query. So here I am inside of Graphical, and I want to create a query to retrieve an e-package from the package registry. I've set up the URL of my GraphQL endpoint. So first of all, I will create a query named getEpackage. And using our entry point, you can see that we have access to multiple fields to retrieve some project, e-packages, or even viewpoints. In our case, we will retrieve only one packages. For that, we need to supply the NS URI of the package that we want to retrieve. Let's use the NS URI of the eCore metamodel. After that, I can ask for anything I want from this e-package. I will just start with its name. When my query is executed, you can see the result on the right. Here, you can see that I have retrieved the name of the eCore metamodel and that the structure of the response, viewer, e-package, name, is exactly the structure of my query. Now, let's ask for a bit more information. I will ask for its NS URI and its NS prefix. Now that we have retrieved more information from the e-package, let's navigate to other concepts. I want to retrieve the name of all the e-classifiers from this metamodel. For that, I can simply use the e-classifiers field and ask for the name. You can see everything here contained in the eCore metamodel. Let's go a step further by asking for what information we can retrieve from e-class specifically. So here we will just consider e-classes and ask if they are abstract. Since our query will start to become a bit more complex, I will extract a part of it inside of a fragment. So for that, I will create a fragment named e-class fields defined on e-class, which will ask if an e-class is abstract or an interface. I can now reuse my fragment and see the result very quickly. We can go a step further by requesting information from the structural features of the class. So now I will use directly a fragment that I will create on the type structural feature. This fragment will ask for the name of the structural feature, whether it is ordered, unique, its upper bound and lower bound. And now you can see that I've received most of the information available from an eCore model very quickly. I don't know what you want to display inside of your web page, but you will be able to ask for anything you want and you will receive exactly that. After having defined your query in a tool like graphical, you can easily integrate it inside of a JavaScript application. Here is an example with React, where you can define in one place both your query and the React component which will use the result. The query is exactly the same as a query which would have been created thanks to graphical. And after reusing it, you just need to give it to your React components. Here we are using Apollo GraphQL, a framework used to simplify the use of GraphQL in React applications. You can see that we can very easily specify the query and the variables to use in order to send a request to the server. Our GraphQL API has been available since Eclipse Sirius 6.1. You can use it from a regular install of Sirius by installing it on top of the optional Sirius Server feature. On top of that, you can install the Auto Start feature, which can start the Sirius server automatically for you when Eclipse is started. This way, you will be able to request some data from your local Sirius instance fairly easily. You can see here some virtual machine arguments to use in order to configure the port of the HTTP API and some other details. In future versions of Sirius, this GraphQL API will be improved. We will give you the ability to customize the way our free services are connected by contributing new types and fields to our schema, and also by modifying existing types and fields. You will also have the ability to reuse only a subset of our GraphQL API if you want to do so. Along the creation of this GraphQL API, we have also worked on providing support for Sirius diagrams in other web applications. Today, we can integrate Sirius diagrams inside of a web page by reusing the existing ODesign configuration. You can see here the basic family sample with its diagram, its tools, and its layer. For this work, the diagram and its layout are computed server-side and then rendered in SVG in JavaScript. Thanks to a WebSocket-based protocol, we're able to retrieve the structure of the diagram anytime it is updated. We can also execute tools or modify the layers of the diagrams. With this work, it is easy to get started thanks to a quick feedback loop. You can, as usual, open your diagram and its definition side by side and update the definition to see the updated diagram in real time. We are leveraging most of the concepts you are familiar with inside of your ODesign, such as node, container, and edge mappings, layers, styles, and more. Here you can see it in action with the diagram in a web browser on the left and the ODesign definition on the right. We can update the label and edges on the ODesign definition, and the diagram will be updated directly. You can see here that the color of both the label and edges has been changed to blue, and we will change the other label and edges to purple. Here is another example, this time using the BPMN designer, where we have modified the tool in order to quickly create a small example. You can see the automatic layout in action this time. We have also worked to be able to integrate Sirius diagram in pretty much anything, including in existing online IDEs such as Eclipse Theia or Eclipse Che. Here you can see our work to integrate Sirius diagram inside of Eclipse Theia, where we have created two views, a palette on the right and a workspace on the left. The workspace uses our GraphQL API in order to retrieve the folders, projects, and files available. The diagram is open in a dedicated editor in the center, and you can interact with the layers and the tools in the palette. You can see once again the automatic layout in action. We have also integrated this work in Eclipse Che, as you can see it in this screenshot. Now let's have a look at what's coming next year. Our main goal for next year is to provide a production-ready version of Sirius diagrams in the web. For the first version, the functional scope will be a bit limited, and some advanced features, such as the support for dialogues or wizard, may not be available in the beginning. You will be able to use this web-based version by reusing your ODesign file with your expression and your existing models. There will be changes in our API, so look for our announcement. We will tell you as soon as possible when we will make changes. Thanks for watching this video. You will be able to find some links in the description below if you want to know more about some of the features that I have explained today. If you've liked the video, don't forget to like it and subscribe if you haven't already.